When it comes to computer systems validation, issues associated with test steps and test scripts often have nothing to do with the test steps and scripts themselves. It's something else. In this podcast, we're going to be talking about the third aspect of computer software assurance. And that third aspect is testing. And when it comes to testing, the problems associated with the testing, as I mentioned a second ago, may not be the test scripts or steps themselves. The problem, the root cause of the problem, may in fact, and often is in fact, related to requirements. And there are characteristics of good requirements. I'll have another podcast that will actually dive into requirements because they are so important. Good software is built upon the foundation of good requirements. The same is true with testing. Good tests are based upon good requirements. And just as a preview, the characteristics of good requirements, and there can be 6 or 8 or 9 depending upon what source you look at. But here I'll tell you 8 characteristics of good software requirements that are pretty common. Unambiguous, testable, you see it's called out right there. Good requirements have to be testable. Clear, correct, understandable, feasible, independent, and atomic. And we'll come back to those. So why am I talking about requirements here in testing, a podcast about testing? Because that is often the root cause. In the previous 2 podcasts, the first one I talked about critical thinking as the first step, the highest level of computer software assurance, critical thinking, whereas before with computer systems validation, it was put at the bottom of the list. Now, computer software assurance puts it at the top of the list. So we had a podcast on that. You can look at the different episodes, and if you didn't get a chance to listen to that, I encourage you to listen to that. And then the next one related to this series in computer software assurance podcast was assurance needs. That's the second level, the inverted pyramid, the change of the paradigm. So whereas computer software validation had documentation first, testing, assurance needs, and then critical thinking, computer software assurance has critical thinking, assurance needs, testing, and then documentation. So again, if you haven't had a chance, go back to that podcast. And we, in this podcast, will talk about how critical thinking and assurance needs applies to testing, specifically as it relates to risk-based validation and least burdensome approach. Then from critical thinking and assurance needs, we will take a look in this podcast about the different types of testing that you can perform. And given computer software assurance, highlight some new things like ad hoc and exploratory testing. And then the association between your requirements and the tests themselves. And we'll also talk about some aspects of the different types of tests we see in computer systems validation, such as installation qualification tests, operational qualification tests, and performance qualification tests. Another thing we'll highlight is the importance of traceability, and does a lot of testing mean that you've done a really good job with validation? That's the topics those are the topics that we are going to cover in this podcast today. Before we get started, I want to thank everybody for listening into the podcast. I wanted to share some good news. We're at episode 7 right now, and it's going very well, actually better than expected. And just to give you a rundown of statistics here, in just a few short episodes, we have reached a global audience. And just to let you know, we're in the United States, Ireland, India, Canada, Algeria, the United Kingdom, Australia, Belgium, Hungary, Poland, and Uganda. So that's pretty interesting that we are in all of these countries, and hopefully it will spread to all of the countries. It takes a little time to do that. So when you're listening to this podcast, make sure you click the like button. That helps out. And also, I wanted to let you know how we distribute the podcast. It's created on Spreaker, and then it gets distributed to Apple Podcasts, Google Podcasts, Spotify, Amazon Music, Podcast Republic, Alexa Media Player, and then Audible, CSA out of India, and iHeartRadio. So we're in a lot of different channels, and expect that as a result, it'll just keep growing. So spread the word, share it, tell other people that you're listening to it, and also let us know the topics that you would like to hear about, and maybe guests. If you'd like to be a guest, reach out to me here, and we will consider bringing you on. We'd love to hear from you. So now let's get back to the topic of this podcast, which is testing. In the four-phased approach that was outlined for computer software assurance, one of the phases is methods and activities. So there's identify intended use, determine a risk-based approach, methods and activities, and appropriate record. In the methods and activities, it talks about leveraging things from the supplier, which is always a good case. Why redo things if the supplier has already performed testing? Even factory user acceptance testing, we see that more in the equipment side of it, but the software vendors will do their own testing. So why not leverage that, especially in a cloud-based software as a service environment where you aren't necessarily performing an IQ anyway. They control the IQ because they are providing the software as a service in the cloud. So there's not necessarily installation. There may be a deployment of the solution to an instance in the cloud, and obviously you'll have to make sure that the installation of that instance and the deployment and configuration is there. But it's not installation like you would see in a traditional installation of software on a server. I was going to date myself here and saying installing from a floppy disk, but that goes way back. So installation on a on-premise server. So it's different in the cloud. And then it also talks about tools to automate the activities. You have automated testing, and we've touched upon that before. We'll dive into it a little bit deeper here. And then the agile testing methods, unscripting ad hoc test, exploratory testing. In addition to that, it talks about taking electronic data capture to record the creation. And how does that really apply with software? Well, you may be testing a solution. Let's say hypothetically it's a LIMS system, and the LIMS system is connected to instruments, and that's an example of testing those aspects of it. In addition to that, with Pharma 4.0, based upon the fourth industrial revolution, Industry 4.0, it's a big aspect of that is Internet of Things, which deals with a lot of sensors and devices. And these sensors and IoT devices are constantly communicating, gathering information, and sharing it. And as we march forward with Pharma 4.0, we'll have more intelligence, artificial intelligence, and machine learning, which will take us into the maturity, technology maturity level, whereby we're moving away from reactionary through proactive to predictive and then even prescriptive. And in order to be predictive and prescriptive, we need a lot of data to see what's coming. And that can come from the IoT devices with the sensors. So in computer software assurance, if we're testing software and we're using prediction in the algorithms inside of the system and solution itself, then of course that could be connected to devices. So that could be something that you would want to include in the approach that you're taking on testing. Finally, it talks about leveraging continuous data for monitoring in addition to keeping your assurance levels up. So if we look at computer systems validation, all too often it's an activity. You finish the validation, you put a stamp on it that it's validated, and in the old paper-based systems, it gets filed away in an archive and forgotten until an audit or an inspection comes up, and then you dig it out and try to make sense of it to answer questions. I'm being a little dramatic, but there could be some truth to that as well. But when it comes to really advancing technology, maturing technology, why can't we take these IoT sensors and devices and continuously monitor all of the key aspects so that not only have we validated a system and it's achieved its validated state, meaning it's performing as intended, but we are monitoring that application so that we will know if it's deviating in any way from that validated state. In other words, it's not performing as intended. It may start having some issues that could highlight the fact that there may be a failure coming, sometimes even an imminent failure. And why can't we do that? Other industries are doing it. We're actually doing it now in our industry, in the manufacturing world, where we could sense things that are happening and predict those. And we can also do the same thing in the computer software world. Let's get back to the first point that we started the show with, and that is the root cause of issues being requirements, and the secret to writing good test scripts is writing good requirements. That is the source of the test scripts. We are testing the requirements. That's the whole purpose of testing. And as I mentioned before, the characteristics of good requirements are, here's 8: unambiguous, testable, clear, correct, understandable, feasible, independent, and atomic. Let me just highlight a few of these. Like I said before, I'll do a podcast that dives into details of requirements because it's so important. But testable, your requirements must be testable. If you can't test your requirements, then you're not going to be able to validate it. And Peter F. Drucker said, if you can't measure it, you can't manage it. Testing is a way that you could measure the performance of your requirement being delivered and operating properly, performing as intended. So when you're writing the requirements, you need to make sure that you will be able to test those requirements. Obviously, they should be clear and correct. They should be understandable. As for feasibility, if your requirement isn't feasible, it's not going to be delivered. You're not going to have to worry about anything being tested because it's not going to be delivered. But there could be a problem if it's infeasible. If it's not feasible, then somebody may miss the mark and develop something that isn't appropriate. And you may end up with some code or some function, some operation inside of the solution that a developer thought was what you meant by the requirement. And since it was not feasible, they created something that would work, but what is working in the code is not what was intended in the system. So you have to be careful with the feasibility of a requirement. It should be independent and not dependent on other requirements. And the reason for that is if I have dependency between requirements, I'll have a problem if I need to remove that requirement, especially in an agile iterative software development methodology. So if I have to remove it and it's dependent upon all the other requirements, then all those other requirements will have to come out as well, which could be a mess. But the other thing with independence or dependence is both independence and dependence. If your requirement is independent, then you could focus your testing on it. Conversely, if there's dependence of your requirement, then your testing is going to have to address those dependencies, which will make your testing much more complicated, convoluted, and more problematic. So your requirements should be independent, so you know what they are, they stand alone, and obviously testable. So when you write your test for that particular requirement, it is for that requirement, and you can adequately test it based upon risk. And then atomic, they should be self-contained, the smallest unit. They stand alone, like an atom. So the atomic aspect of the requirement is that it is not divisible. It's in its smallest state, stands alone. That is the aspect of requirements as it relates to testing. Again, to summarize, the root cause of most testing issues can be related to bad requirements. If you're going to write good tests, it's important to first start with good requirements, and those good requirements are based upon 8 characteristics, or sometimes 6 or 9, depending upon what resource you look at, but typically 8 characteristics of a good requirement: unambiguous, testable, clear, correct, understandable, feasible, independent, and atomic. Again, we touched upon critical thinking and assurance needs, and in that aspect, I want to call out risk-based validation and a least burdensome approach. With risk-based validation, again, it came about in 2002 through FDA guidance, and we should be using that, but we need a little refresher to remember to do that. And that's one of the things that Computer Software Assurance CSA gives us, is to refresh our memory that we should be doing risk-based validation. And with risk-based validation, the bottom line is you know what to test based upon risk, which in turn tells us the test rigor to apply. And the definition of rigor is exact, careful, strict. So if we have a high degree of rigor, it's very exacting. We're exceedingly careful and very strict with our testing requirements as it relates to that requirement. Now, with the lowest level, I'm going to skip medium for a minute here, but with the lowest level, then we don't have to apply that high exacting degree of rigor. It's low risk, so if there's a problem, then it won't have an impact. And as I have said before in previous podcasts, if there is a problem, then it wasn't a low risk requirement in the first place, and you need to revisit your risk management process. So if it is truly low risk, then you don't have to be as careful, because there will be no impact, because there is no risk, essentially low or no risk. And you don't have to be as strict, because it's not high risk, it's not even medium risk, it's low risk. Now when it comes to medium risk, that's where we have to use discretion, and we need qualified individuals, a team of subject matter experts. They're qualified because they're educated in their respective areas that they're subject matter experts in, and they are trained for the company procedures and trained in industry, and they also have experience in the industry as well. And so you want to make sure, according to the requirements of the regulation, individuals are qualified by their education, experience, and training. And that's really important when it comes to any risk assessment, but especially medium risk, because you have to determine what is the appropriate degree of rigor to apply to that. When it comes to testing itself and risk-based validation, we need to know the level of risk, high, medium, and low. And as a result of that, base the testing upon the appropriate level of rigor commensurate with that particular test script that is in turn associated with a requirement. Now let's talk about least burdensome. Here we need to make sure that we know what is overkill, and we also need to make sure it's appropriate. And what has happened in the past is we have tried to validate everything to the highest degree of rigor, which means that we spent too much time on low, no risk requirements, maybe overkill on medium, and not enough time on high because resources are limited. And so we were trying to boil the ocean, if you will. We were trying to test everything to the highest degree of rigor, and we didn't have enough time and resources, and something had to give. And a lot of times what happened was the high risk was under-tested, under-validated, and the low was over-tested, over-validated. So a least burdensome approach looks at that to make sure that we don't create a burden on the entire project, a burden on the developers, a burden on those writing requirements, such as business analysts, the validation engineers, or whomever are writing the test steps and test scripts. And this burden, if it is too much, if it's most burdensome, then it's going to drag everybody down. And the problem there is quality suffers. People try to find shortcuts. And as a result of looking for shortcuts, compliance suffers as well. And so it's really important to have a least burdensome approach that is appropriate to the degree of risk associated with these requirements and test steps. Least burdensome will result in higher quality and compliance. In addition to what we learn from critical thinking and assurance needs, we also need to take a look at the different types of testing. And in a previous podcast, I highlighted these that are really identified in computer software assurance. They've always been around, but they're called out specifically in computer software assurance. And that happens to be ad hoc exploratory testing. And we'll touch upon some challenges associated with this. But in addition to that, ad hoc exploratory, we also have the traditional computer systems validation, scripted tests that are pre-approved protocols, and we all know what that is. Now, the problem with ad hoc exploratory and automated testing is what's the objective evidence? If you're just doing ad hoc testing, what are you proving? How do you make sure that you can show that you have done the ad hoc exploratory testing? And if you're doing automated testing, what are you capturing? Because you are not executing a test step by a human being performing the execution and possibly capturing a screenshot. With automated, a person is writing an automated test script and running it, and the software is actually testing the system. With ad hoc, there isn't necessarily predetermined steps with, this is the expected, this is the actual, take a screenshot, pass, fail, sign off on it. It's ad hoc testing, and exploratory is the same, very similar to the ad hoc testing. So you need to take a look at what is the objective evidence. In other words, in order for this to be defensible, you really need to have a risk-based approach and document that ahead of time. Don't do it afterward. Critical thinking, assurance needs, you're figuring that out ahead of time. So as you're approaching the problem, you have a good feeling and a strategy how you're going to approach it. And then when you execute, then you execute according to whatever your strategy is. But how are you going to capture all of that objective evidence that can be provided if the need comes up? A problem occurs and you need to figure out where the problem is to fix it, and you identify that internally, or an internal audit, or an external audit, or even an inspection. Hopefully you're finding these things internally and resolving them. In the best world, you have quality by design, and you are designing all of this into the system in the first place to even identify problems before they occur. And in the future, self-correct, that would be ideal, autonomous systems. But let's get back to reality here. Whereas you want to identify these things internally avoid them if at all possible, but problems do happen. So when they happen, identify them internally. What you don't want to have happen is you don't know what's going on and there's a problem and somebody from the outside happens to find it. That doesn't show that you really have good assurance of your quality, that you may not have good control of your systems or a good validation process, change control configuration management process. So there could be several things associated with not being able to identify your own system issues and correcting them internally. The other thing to take a look at is who writes the test scripts. It's extremely important. I mean, you are performing a validation of a system, and this is a regulatory requirement. It's a requirement. It's a law. You have to validate systems. It's important that you have the right person writing the test scripts, because if you don't, you may miss the mark altogether and not adequately test the test steps. You may find out about it later if a validation leader quality looks at it and says this is inadequate and rejects it, but time is wasted there. So make sure that you have the right person writing the test scripts, or at least if it's more of a junior level person, they get the right guidance and direction in order to write the test scripts, test steps correctly in the first place. And good requirements will help them out because they'll be clear and testable and concise and unambiguous, all those 8 characteristics. So again, we get back to good requirements is a key. But you also want to make sure that a qualified individual writes the test scripts, right? And then who will review and approve? Does everybody need to review and approve it? Do you really need to focus in on critical individuals that can review and approve and cover all bases? The challenge here is if everybody reviews it, then you will create overhead, and overhead is going to require more resources and time and could slow down the process, and slowing down the release of a system may actually be more risky than it could be risky slowing down the release of a system. Let's just put it that way. So who needs to review and approve? Well, again, these individuals must be qualified, and the right people, the qualified individuals, should be included. Obviously, quality as a final signature is required, and so that is what you would need to have, a final quality signature. But in addition to quality, who else needs to do it? Is it one more individual? Is it 2 more? Your own organization, based upon your quality system, will determine that. But make sure it's the right people at the right time, and only the right people, and not a whole bunch of people that don't necessarily add value or do not create extra overhead that is slowing things down, again, with no value. That's something you would have to determine yourselves. We'll get to the next point, number 4 here. So if your user and functional and design requirements are correct, guess what? They're testable. And if you've really written good user requirements, good functional requirements, and good design specifications, and these are different. User requirements are the user's intended purpose, intended use of the system. The functional requirements are all of those requirements that the system needs to perform to meet the needs of the users. And then the design specification, or the design details, that are the elements and components and necessary things that need to be in the system that allows the functional requirements to be developed and delivered, that in turn meet the user requirements. So user requirements lead to functional, functional to design, and then going backwards, design supports functional, functional supports users, and the user requirements is the intended use of the system. So if your requirements are done right and they're testable, then as a result, your installation related to user, related to design specification, and your operational related to functional, and your performance related to user, your IQ, OQ, PQ, will relate to your design, functional, and user requirements. it's the traditional V model. It's just helpful to remember it that way. The other way of looking at it, user requirements relate to performance qualification, functional requirements relate to operational qualification, design specifications lead to installation qualification. When it comes to the IQ, we're focused on design of the system and how to install the system. Maybe some challenging test scripts, but do you need a challenging test script for every step in the installation? Does the traditional step-by-step expected actual pass-fail, does the traditional way of writing a CSV test script make sense for every step of the installation qualification? You'll have to determine that. But here's the point. You'll know if it's installed correctly, and you'll know it in validation. Well, you'll really know it in the design environment, but when everything is done and the developers have done their testing and everybody from the technology side says, yes, this is ready to move into validation, it should be working because validation should validate the fact that it works. Validation shouldn't be the time that you find and test errors, although that's where you find and you test and you find errors there. But that's not the purpose of validation. The purpose of validation is to prove that the system performs as intended, and that's the validation environment that proves it in that environment before you release it to production. When you install the system in the validation environment, that environment mimics production. And if it doesn't work in validation, it's not going to go forward to production. And you're going to know if something isn't right in the installation. So you could go back to the design and fix it, and then go back into validation to make sure it works right. The drive home point here is that your IQ is going to work or not, and you need to make sure that it's adequately tested, but not burdensome. So it's a risk-based approach that's least burdensome. And part of the risk to consider is that if it's not installed properly, if it's not installed correctly, then it's probably not going to be stable. It may not work at all. And consider that in your risk-based approach when it comes to writing the IQ. Done right and effective, then it's very useful. The IQ scripts are very useful because you can use those scripts for disaster recovery, business continuity. It's how you install that system. An IQ should not just be for validation. The IQ is if it's written right, could be used as a script to reinstall the application later or reconfigure the application. Or it could be the basis of your admin ops SOP for disaster recovery business continuity. So invest the time in the IQ so you could get a lot of benefit from it in addition to just the installation qualification associated with validation. Operational qualification, that's the next thing to talk about. It's the largest piece typically, whereas IQ's pretty small. Usually the OQ is typically the largest set of test scripts, and that's because it's related to the functionality. The functionality of the system, there's a lot of functionality to accomplish a user's requirement, and that's why the OQ typically seems to be the largest. When it comes to that, consider screenshots. You can have too many screenshots, and again, it becomes burdensome when you're taking a screenshot every test step. Now, some may not like it that I just said that. Some may believe that you need a screenshot for every test step, but that's not written down in the regulation anywhere. In fact, we should have least burdensome risk-based approach. So yes, if it's high risk, if it's really high risk, we have to have a high degree of rigor. It has to be exact, proceed carefully and strictly, and prove it works. And in that case, use screenshots to prove that it was done right, because that is high risk. Medium, it's discretionary. Leverage the subject matter experts to determine that. And low risk, again, if it's low risk, if there's a problem, it's not going to have an impact. And as such, do you really need screenshots for every low risk test step? That's up to you to decide, but think critically when it comes to screenshots what's necessary, what adds value, and what doesn't, what may be too much. As a matter of fact, too many screenshots will dilute the importance of screenshots. It's the needle in the haystack problem. If you have a haystack full of screenshots and you're trying to find the problem, you have so many screenshots, you may not be able to find it because it's buried in amongst them all. And that's why you really want to focus your screenshots critically, apply critical thinking to make sure you're taking the right screenshot or screenshots at the right time. Now we'll move into performance qualification. And performance qualification is to demonstrate your system is performing as intended. That is the whole purpose of validation. So design is to install it right. Functional testing is to prove all the functionality of the system is working. So now it's installed, all the functionality is working, but does the system meet the user's requirements? Does the system meet the intended use of the system? And that's where performance qualification comes in. And this is associated with the user requirements. When we think about performance qualification, we may get into the trap where the system must respond within 10 seconds or 20 seconds. And sometimes these could be made up. For example, if you have a requirement that after a user presses a button, the system should respond within 20 seconds, what happens if it's 21 seconds? Well, according to the protocol, it's an error and you have to raise a deviation. But if there's no impact and that was just a made-up number because it was a nice to have, 20 seconds would be ideal, or 10 seconds or 5 seconds, but there's no impact to the system whatsoever if it's 21 or 25 seconds. Why did you have that performance requirement in there in the first place? A lot of times those could be written into the test step, and they're not even based upon a user requirement. Or you may have a scenario where you write a test step that includes numbers of seconds in response time, 10, 5, whatever the seconds may be, and then quality or somebody calls it out, you have a test here based upon 10 seconds, but it's not related to a requirement, so somebody goes and creates the requirement, but that's completely backward. The requirement should exist as a user requirement, and then you test the requirements, not the other way around. So be careful with performance requirements and test steps inside of a performance qualification. How do you know what the user's intended performance of the system is, what the intended use of the system is? Well, this is where a process flow comes in very importantly. So if you have a process flow diagram, then you're going to know the processes that exist, that the system is helping the user perform or performing on behalf of the user to automate things. Having that process flow will really help you and should be one of the early things you've done in the conceptualization and prior to the design and development of the system in the first place. You should know what the process is. And if you have that diagram, it's going to be really helpful in developing the performance qualification test scripts and test steps because you could base it upon the process flow. From the process flow, you're also going to have data flow diagrams, and that's really helpful for risk-based approaches. You will know where the critical data is because it's associated with a process step that is generating, the acquiring, managing, outputting critical data. So that is a key thing. You know where the critical data is, so therefore it could be a high risk, and as such, you would create a test associated with that high risk, and you can put that in the PQ, and you know exactly where to put it because you know where the data is and you know where the process step is. So again, a good way to help you in developing the PQ, the performance qualification, is to have and leverage a process flow diagram and data flow diagram, and that will help out. And don't get into the trap where you're just creating performance requirements because you think that performance has to be measured in time. A lot of times performance could be measured in transaction. Successfully create a document, successfully approve a document without associating it with a time constraint that is not based upon reality. That's something that you made up. And then it brings us to traceability. And unfortunately, this is last, but it should be first. And when you're writing your requirements, you number them for a reason because you need to account for the requirements. And that's when you should start the development of your traceability matrix. It's the requirements. And then you can use tools throughout the entire process or use it as a tool throughout the process. And that's an ideal scenario. You're writing the requirements and you're starting to trace them from the very beginning. And as you're writing your test scripts, the traceability matrix is building. Now, if you're in a paper-based system, you're not going to have that capability because it's all manual. But if you're starting to leverage new tools and technologies, then traceability can be automated because that's what these tools do. They're based upon relational database management systems, and they have the ability to reference requirements to test steps and vice versa, and it can help automate the whole process, allowing you to use that as a tool throughout the entire development and validation efforts into the actual production use of the system, so that if there's a change and you're going to change a requirement, then you know already that it's associated with certain test steps, and so that helps you out along the way there. So a traceability matrix should be a tool used throughout the entire software development lifecycle, in addition to the entire validation lifecycle. And ideally, it's automated, and the way you automate it is to digitize your validation, moving away from paper-based solutions into paperless, digitized electronic validation lifecycle management systems. When you do that, then you have the links to the scripts and the tests and the links to the requirements. You could see if there's any gaps. You can see if a requirement is adequately tested. You could see the test steps that are actually testing requirements. And so it's an extremely helpful tool. A lot of times what happens is the traceability matrix gets left off until the end. And in the end, you have a big effort to go and complete the traceability matrix, and it sometimes gets delegated to somebody with time on their hands, which may not be the right person to be developing that. All right, so again, the right person at the right time to develop that. The traceability matrix is extremely important. It's the mortar that holds the validation together. And just to stress the importance, that's as an auditor, that's how I used the traceability matrix to read the plan, what you said you're going to do, the summary report, what actually happened, make sure it made sense, take the traceability matrix, pick a few that gut level instinct is telling me or that I already know I want to take a look at, and trace them through the entire validation effort to make sure that the requirements are there and that the requirements have been adequately tested, and that's what the traceability matrix does for you. So this podcast was testing needs as it relates to computer software assurance. We talked about the root cause of a lot of testing issues being requirement-related issues, and we highlighted the 8 characteristics of the requirements: unambiguous, testable, clear, correct, understandable, feasible, independent, and atomic. We also touched upon revisiting critical thinking and assurance needs, specifically as it relates to risk-based validation, how we should be using risk-based validation, and that's been around. The guidance was just issued in 2002, and so it's been around a while. We should be using a risk-based approach pretty much in everything we do, especially when it comes to validation. And least burdensome, because if we burden things down, it's going to cause problems, shortcuts, quality issues, and people trying to find ways around it, and we don't want that. We don't want to burden our processes, because if we burden them, they're destined to break. And then we talked about, from critical thinking and assurance needs, the different types of testing we can use in CSA, such as ad hoc, exploratory, automated testing, and even traditional CSV scripted testing with pre-approved protocols. We touched upon why it's important to create a regulatory wrapper, because these ad hoc, exploratory, and automated tests don't produce the same validation artifacts that traditional CSV does. So we have to make sure that somehow we are capturing objective evidence that could be used to defend our validation activity. You put a lot of hard work and effort into the validation. You don't want it to be unproven. You want to support the fact that you did it and you did it right. And that's why you need the objective evidence to do that. We also talked about how the installation, operation, performance, qualification scripts are based upon requirements, how the user relates to performance, functional to operational, design to IQ, and the importance of each, even how the IQ shouldn't be burdened, the right testing at the right time. It helps you know if it's installed correctly, which can be leveraged in your risk-based approach. If there's a failure, then it's not going to work, and that's going to tell you your IQ isn't working. We moved on. One thing I want to mention with the IQ that sometimes gets overlooked, and I should have mentioned it before, but log files. All too often we don't leverage the power of log files. So the systems actually generate logs when they're being installed and operating. So not only can we use log files as objective evidence when we're executing our installation qualification scripts to capture that and store that, but we could use those log files to help us assess the health of the system. It will start telling us, if a good log file, if there are problems that are going to happen. And when you're writing your administration and operational SOPs, they should leverage the power of the log files. So the log files are not only very useful in the installation aspect of it, but it's also useful in the operation. And by the way, it would be good to have the design specification to include log files, or even the functional, wherever it's appropriate, that the system should have log files. Even the user requirements can say that the system should be able to provide insight into the health of its operation through the use of log files. So I really want to call that out as something important. When we talked about the OQ, it's one of the largest. Be careful about screenshots. With the PQ, we talked about make sure that it's really testing the system that is performing as intended, and don't get bogged down in made up requirements of, seconds of response time. It should be an actual real requirement that's needed, and not something that we just make up because we think we have to because of performance. And leverage the power of a transaction-based approach that is leveraging a process flow diagram in conjunction with a data flow diagram, and then the traceability matrix as a tool used throughout. Great being with you here on this podcast, and I believe the next podcast we'll talk about is requirements. I touched upon them here, but again, it's so important that we should dedicate a podcast specifically to requirements. It's how a good system is conceived, designed, developed, tested, and delivered. And that is it. All of those are extremely important. So maybe that'll be the next podcast. Stay tuned. You'll see if it is.